Well, hello 1P and welcome to Measuring Right Triangles, otherwise known as the Pythagorean Theorem. So our goal today, I can use the Pythagorean Theorem to calculate missing sides in a right triangle. Now if you leave grade 9 math remembering nothing else, the Pythagorean Theorem is what I really want you to remember. It is very useful for sort of all disciplines of math, whether you're talking about carpentry or anything else. Pythagorean theorem is very, very useful. Now, at first, it might not seem so because all we're really talking about is triangles, but there are applications all over the place, and hopefully you will see that after a while. So, measuring right triangles. Pythagoras, who discovered it, he was an ancient Greek mathematician, discovered that whenever you have three squares, where the area of the first two, so here I have a square that is 9 centimeters squared, or 9 square units, and here is a square that's 16 square units. Together they make up a square that's 25 square units. Whenever you have this situation where you have those three squares, if you put those squares together, so that their sides are touching, what is formed in them there is a triangle. And that triangle, each side of that triangle is the same length as one of the sides of each of those squares, where the biggest side of the triangle, or the biggest square, is called the hypotenuse. And so how we write this relationship down is that c squared, where c is the hypotenuse, c is always the hypotenuse, which is the longest side. Okay. C is always considered the longest side of the triangle. So if I square the hypotenuse of the triangle, then I get this square. And I have to square the other two sides so that I get this square. Because remember, when we're looking at this, we're only looking at a triangle to start with. So there's my triangle, and it says that if I square this side, and we can do it with a diagram or we can do it with numbers, and then I square the other two sides, that these two things here will perfectly add up to this thing. And that's what this says. The big one equals the smaller two squares added together. Now we saw that before because that's where these came from in the first place. And I picked the nicest ones to do. I picked the 3, 4, 5 triangle here, where we have a side length of 3, a side length of 4, and a side length of 5. That's the nicest one to do. Now there are other triangles where, well, all right angle triangles follow this, but their side lengths aren't always nice even numbers like that. And there are a handful that are nice even numbers. Now I'm going to show you this in a couple of different ways through demonstration of fairly brief YouTube clips. So here's the first YouTube clip where someone has created this wheel using, and they've got these little containers full of water here, and they're going to show you that the water in each of these two containers exactly equals the water in the big container simply by spinning. And they're exactly equal, so that shows us that those two rectangles, or those two squares, are equal, together are equal to the big square. And I'm going to show you another one. This is kind of a neat little animation. And we'll let it roll. So there's the Pythagorean theorem. Now that you know what it is, let's use it. So here we go. This gives us a way of solving for the sides in a right triangle if we already know one side. So in any triangle, and we shouldn't have the squares on here. Stroke them off your page too if they're on there. In any right triangle, the square of the hypotenuse, where the hypotenuse is C, the longest side opposite the right angle. So we can always find the hypotenuse because this side, this angle in here, sorry, not a side, this angle in here, the right triangle, this little square always points at the hypotenuse. It kind of looks like a little arrow towards the hypotenuse. And there always has to be a right angle. If there is not a right angle, you cannot use the Pythagorean theorem. And sometimes I'm going to call it side 1 squared plus side 2 squared equals hypotenuse squared, because A and B and side 1 and side 2, it doesn't matter which one's which. I could have called this one up here B, and I could have called this one down here A. It does not matter which one is which as far as the Pythagorean theorem is concerned. What really matters is that C in the Pythagorean theorem is the hypotenuse. So example number 1, find the hypotenuse of a right triangle that has sides 5 meters and 10 meters. So the first thing I'm going to do is draw my triangle. And it says my sides are 5 meters and 10 meters. Now this doesn't look like 5 and 10 because they kind of look the same, but math diagrams are rarely done to scale. All they're really doing is sort of giving you some kind of visual thing to look at while you're doing your question. And we want to find the hypotenuse. So I knew to put the 5 and 10 on these two sides because this little triangle points the way to the hypotenuse, which we're going to call C. And we know that C squared equals A squared plus B squared. I wrote it kind of backwards up here than I did before. It doesn't matter. An equal sign, as long as the two sides are the same, it doesn't matter which order you write them in. Okay, so C squared equals A squared plus B squared. In this case, we have 5, and we need to square it. And we have 10, and we need to square it. So 5 squared is 25, and 10 squared is 100. Now you always have to do the squaring first because remember, order of operations tells us that you do brackets, which there are none, exponents, which is the squared, and then division and multiplication, which we don't have any of, and then addition or subtraction, and we have that one addition. So we'll do the addition now. It was 125. Now, that tells us what C squared is. We want just C. What this has given us, what this 125 tells us, is that if I draw a square off of here, this is 125 square units, or in this case, square meters. So if I draw that, that's 125 square units, square meters. I just want this. I only want the straight line distance. I want this thing. That's all I want. And so we have to do the opposite of squaring, which is square rooting. So I need to take the square root of 125. Now, all calculators have a square root button on them. They look like the symbol that I just drew down there. Some calculators you have to press in 125 and then hit the square root button like this one. And we're going to round it to 1 decimal place. So this is 11.1, but now I have to look at the next number. And the next number is 8. So this 1 gets bumped to a 2. So it's 11.2. And that is approximate because we had to round it and our units was in meters. Okay. So next question, this says, sometimes we already know the hypotenuse. In this case, we rearranged the formula to show that side 1 equals hypotenuse squared minus side 2 squared. And this wasn't rearranged. A squared equals C squared minus B squared is what that should have been written as. Okay, or side 1, whatever side we're trying to find. Okay, this is always the side we're finding. Side we are finding. The side we are finding squared equals the hypotenuse squared minus side 2 squared. Now here's the important thing is, if we're already given the hypotenuse, when we find the other side, we're going to have to subtract rather than add. When you find the hypotenuse, you add. When you're finding the other side, you subtract. So let's look at the next question. If the hypotenuse of a right triangle is 18 centimeters, so I'm going to write this on here. The hypotenuse, we know where the hypotenuse is because this little square is going to point the way. So this is 18 centimeters. And one of the other sides is 3 centimeters. Now it doesn't matter where I put that 3. I can put it on this side or I can put it on this side. Doesn't matter. Now this side looks like it might be closer to 3 than the other side because this side's a lot longer. But it doesn't matter where we put it. So 3 centimeters. What is the third side? So we got to pull out our Pythagorean theorem, which says that the side we're looking for, we're going to call it A, and we square it, is going to be c squared minus b squared. Since we are finding the other side, we have to subtract. So this side is going to be called A, and we'll just put a little A on it. If there was another letter already on there, we could just use that in our formula. It wouldn't be a big deal. Okay, so C is always the hypotenuse, so I take 18 squared and I subtract 3 squared. Now 18 squared, 18 times 18, remember that, and I'm going to put that up here, 18 squared equals 18 times 18. You got to remember what squared means. It doesn't mean 18 times 2, it's 18 times itself. 18 times 18 is 324. And 3 squared is 9. And if I take 324 and subtract 9, I get 315. Now again, what this has given me is a squared. This has given me, if I draw a box off of here, it has given me what this area is in here. It's not what I wanted. I just want to know what this side length is. So I have to do the opposite of squaring something. I have to square root it. So I need to take the square root of 315. And the square root of 315 is 17.7 if I round it to 1 decimal place. And you can try it on your calculator too to make sure that you get the same thing, 17.7 centimeters. Now the last question that we're going to look at says, on his way home from school, Kyle has to cross a field that is rectangular in shape and is 150 meters long by 85 meters wide. So here's our rectangular shape, and it's 85 meters wide and 150 meters long. How much distance does he save if he moves from corner to corner along the diagonal instead of going around it? So here's the field. Presumably it's, a fenced-in field that he probably really should go around it. But we want to know, can he cut across it like this or go around here to here, which will be shorter? Or how much distance does he save? We know that cutting across is going to be shorter. But how much shorter is it? Well, all of these are square corners. So this square here points the way to a hypotenuse in a triangle. And if you don't see a triangle, I'm going to show you the triangle right now. Here's our triangle. Half of a rectangle makes up a triangle. So there's our right angle triangle. And what we're trying to find here is the hypotenuse, which we call C. So we go C squared equals A squared plus B squared. And that's 85 squared plus 150 squared. Well, 85 squared plus, here, let's pull this in. 85 squared is 7,225 plus 150 squared. 150 squared is 22,500. 22,500. And then we're going to add those two things together. Plus 7,225. And we get 29,725. 29,725. Now again, that's c squared. That is not our final answer. To get the c, we have to take the square root. And that says it's 172.4. So 172.4, and that's going to be in meters. So if he cuts across, it's 172.4 meters. So this is cutting across. Whoops, that's not what I wanted to do. I want to select these and move them over a little bit. There we go. Now, to go around, so let's just put the words up here. Let's say this is across, and this is around. To go around, the distance will equal 85 plus 150. And 85 plus 150 is 235. So he's saving quite a bit. Here, 172 to 235. Okay. But how much does he save? So we're just going to write saved is 235 minus 172.4, which the calculator will tell us 235 minus 172.4 is 62.6 meters. So it saves him a bit of distance, and since this is a word problem, we should end it with a statement. He will save 62.6 meters of walking distance. And that concludes this video on the Pythagorean theorem.